Please all mute yourself for that meeting. If you have any questions, please type them in the chat. Yeah, if we have time at the end, I will directly answer the questions. If not, then I will follow up and you will get answers to that questions. Yeah, so let's start with the presentation. And so now it's working. There are some sections in that presentation that I will go through. First of all, there is a high-level overview on the RLS 500. And by the way, so you can also use those slides if you are talking to your customers. So that's how the presentation is also structured. So first of all, there will be a general introduction to the RLS 500, then a more detailed technical training, then some sales information that includes features and benefits, but also what needs to be considered when ordering the RLS 500. So let's start with the introduction of the RLS 500. And first of all, why is radar technology for measuring water level so good? So it has benefits over other technologies. So there's literally little to no maintenance required. There are no components in the water. So first, you don't need to install components in the water. And second, those components cannot be damaged by debris or containment. It is unaffected by temperature changes in the temperature, pressure, or vapor. So unlike ultrasonic level measurement, radar level measurement is unaffected by those influences. And so that means it's really best to use radar when the surface of the water is relatively smooth and free from turbulence. So either in rivers, creeks, channels, or also lakes, radars can be used for determining the water level or the distance to water in that case. And yeah, take care that you select a measurement site that's rather smooth. It also depends on your measurement task, of course. And yeah, also it's of course best to use radar when there is already an efficient way to place the sensor above the waters. So if there are already some bridges or structures available, if you have a very wide riverbank, in that case, of course, often the use of pressure level sensors make more sense. So the RLS 500 is the next generation radar level sensor by OTT Hydromet. It will replace the existing OTT RLS radar level sensor. It has an advanced 80 gigahertz radar technology. It comes along with an IP67 robust housing, and it can be seamlessly integrated into data loggers, environmental data loggers, but also PLC system. And it ensures accurate data collection with high reliability. It has minimal maintenance requirements and a very low total cost of ownership. Building on decades of experience with the OTT RLS, the OTT RLS 500 has now been enhanced with some new features, or with a lot of new features in the end. So first of all, and most important to mention, it is using a different radar technology now. We are, with the RLS 500, using the state-of-the-art radar frequency of 80 gigahertz. With that new radar technology, we can increase the accuracy to ±2 millimeters across the whole measurement range, unless the old RLS where you only had the high accuracy in a certain range. The beam angle is way smaller now. The beam angle is only 8 degrees. And also very important, there is no blanking distance. So no distance between the radar and the measurement surface where you cannot measure. So you can really measure up to the radar. That increases the flexibility for installation. The communication is done via SDI12 and RS485 interfaces via the SDI12 and Modbus RTU protocol. It does not come with a 4 to 20 milliamp output anymore as the old RLS did. In addition, it has an integrated inclination and humidity sensor. And yeah, you see already some parallels here. 2 years ago or 3 years ago, we launched the new PLS 500, so the new pressure level sensor. And there are a lot of parallels between the new PLS 500 and the RLS 500. For example, this integrated inclination sensor and humidity sensor. Also, a parallel is that the sensing frequency has been increased. In that case, the RLS 500 can measure with a frequency of up to 8 Hertz. So what does make the RLS 500 a smart sensor, as we call it? And again, here you have the parallel between the PLS 500 and RLS 500, as that slide is exactly the same that we are using on the PLS 500. Yeah, so the RLS 500 includes built-in QA/QC features, metadata to verify the sensor performance and validate the data remotely. So it gives you confidence that your data is accurate. It can do that by data processing that's built in. So it can internally convert this high frequency measurements to statistics such as averages, min, max, but also you can have user-defined measurement intervals or averaging intervals that gives you more value for your post-processing and analysis. There's also an internal discharge calculation, so you can automatically calculate the discharge from either a rating table or the ISO exponential formula. That needs to be set up via SDI12 commands, and then the RLS 500 can also calculate the discharge for you. In the sensor, you also have a position sensor that allows you to remotely monitor if the sensor position has changed in the field, either due to vandalism or because it got hit by a tree or something like that. So you immediately know in the office, hey, I don't trust the data anymore because the sensor position has changed. And that status flag comes along with every measurement. So you immediately know when you receive the data that something's wrong. That to the internal humidity sensor. So the sensor housing is completely sealed, and due to that, the let's have a quick look on what differentiates the new RLS 500 from the existing RLS. So for those of you who are not familiar with that, that one is the new RLS and this one has been the old RLS. You already see here, it got way smaller. So just for reference, this top part, the swivel mount or wall mount, is exactly the same so that you can also really compare the sizes. So this one here is exactly the same than this one here, and the rest did decrease. So here is a comparison table. First of all, as mentioned already, the radar frequency is now the 80 gigahertz frequency band versus 24 or 25 gigahertz from the RLS. The sampling frequency also, you gain more flexibility here, so you can choose between a half second, so 2 hertz, and you can do averaging with or up to 60 seconds or 59.5 seconds, versus with the existing RLS, with the old RLS, you are limited to 2 to 20 seconds. Also, the accuracy improved, and also the beam angle decreased. So we went from 12 degree down to 8 degree. This gives you way more flexibility when installing the sensor, the RLS, because the measurement footprint on the water gets smaller, and so you can also measure in smaller channels, in smaller rivers, or you are more flexible. You can get closer to a wall or closer to any obstructions. The measurement range is now 0 to 30 meters compared to 0.4 to 35 meters. So the overall measurement range decreased a little bit, but there is no blanking distance anymore. A big mechanical difference besides the size is that this sensor connection, so the wiring, is now done with a plug connection. So you will receive the RLS 500 with a cable, so you can order different cable lengths and then directly plug the cable into the RLS 500. And the existing RLS and the old RLS, there was a wiring box where you could directly wire any cable. That created a lot of issues. Mechanically, it was a difficult concept to get that done and get that sealed. And so it was difficult also to open that wiring box after some months in the field. Another mechanical difference is that the housing is now completely sealed. We still have IP67 now, but now it's completely sealed. The old RLS was using the diving bell principle. So it was open at the bottom, but when flooded, it was still watertight. And then there are the firmware features that I already talked about that are now on the device. And then the difference, the 4 to 20 milliamp communication got replaced by the Modbus RTO communication. Yeah, just a little technical excursion to the sensing technology. The RLS 500 uses a frequency modulated continuous wave radar, short FMCW. And this is acting at the 80 gigahertz frequency band. This is currently used by a lot of car manufacturers for the radars that they are using in their cars. So it's widespread, and it became kind of an industry standard. And in comparison, the RLS is using a pulse radar, so it emits pulses of electromagnetic waves at a regular interval, and then the sensor measures the travel time, versus the RLS 500 emits a continuous wave that varies in frequency over time, and the sensor measures the frequency difference between the transmitted and received signals. This technologies allows us a higher sensitivity and accuracy, and especially a better signal to noise ratio makes it more reliable in challenging environment. So feedback that we got from users that are using the 80 gigahertz technology is that especially with sun glare and difficult situations, the measurement results you get are way better than the results you get from a pulse radar. And at the end of this first section, just a little comparison of technologies for water level measurement. So besides shaft encoders, there are 4 different principles. So the radar, ultrasonic, pressure level sensors, and bubble level sensors. And in the end, they all, of course, measure water level, and the pressure level sensors, in addition, can provide you temperature readings or even conductivity readings. Accuracy and reliability is very high for radars, pressure level sensors, and bubblers. Here, with accuracy and reliabilities, ultrasonic sensors have their weakness, so they are not good at that point. Installation and maintenance efforts are rather low for radar and ultrasonic sensors as long as there are structures available already. Pressure level sensors and bubblers are often more difficult to install and maintain as you have things in the water that need to be installed and maintained there. The cost is in a medium range for all the high accuracy and reliability sensors. It's a little bit lower for ultrasonic sensors, but overall radars give you a perfect combination of high accuracy, high reliability, and at the same time, low installation and maintenance effort. So that and where it is used, and now let's do a little bit more deep dive into the technology or into the features of the RLS 500. First of all, how does it fit into a hydro station? Here you see a classical hydro station, how you will find it in sometimes with more sensors, sometimes with less sensors all around the world. You have level sensors like the RLS 500 here. You have velocity sensors. You have pressure level sensors or bubblers. You have often a stuff gauge at the side of the river bank. Often there are cameras used. And in addition, you have precipitation sensor. And all those sensors are connected to a data logger in a gauging station. And from there, the data is sent to a cloud or a data management solution. That means the RLS 500 gets connected to a data logger, usually via SDI12, or gets connected to a PLC system, usually via Modbus. And from there, the data is transmitted to the data management system. So what sensors and measurements are available? What data is available? A lot of things I talked about already, but here a little bit more detailed. The level, you can get either the distance to water, which is of course the base measurement of a radar. And then if you enter the reference value in the radar, you can also directly measure the water level. That can be done in metric or imperial units. They can also directly be ordered in metric or imperial units. Also, that's new, there is a high frequency HF option. So usually the standard version samples or measures with 2 Hertz, so 2 times per second. There's an HF option, high frequency option of the RLS 500 that allows up to 8 Hertz individual distance measurements. The accuracy, as I said, is 2 millimeter, plus minus 2 millimeter. In addition to the level measurement, which is of course the main sensor, there is that position sensor, the inclination sensor included. And yeah, it gives you a status flag as soon as the sensor deviates more than 5 degrees in any direction from the 0 point. So it gets configured or calibrated in the factory, and then in the installation, as soon as the deviation is more than 5 degrees from the 0, the status flag is set, and you know already with the measurement that something is wrong there. Same with the internal humidity. As soon as the internal humidity is larger than 90% relative humidity, a status flag is set in the sensor along with the measurement. Yeah, and with that, we already get to the status and data quality indicator. As I said, the RLS 500 is designed for hydrologists, and so always having that in mind, this data should or will support you in determining already in the office if something's wrong with the data or if you can trust the data. First of all, the device status, which gives you an indication if the sensor itself is operating as it should. So it gives you different status messages. For example, the sensor orientation has changed, or the sensor is not pointing downwards, important information. Then it gives you the number of valid measurements. So one measurement is the average of several samples. So for example, you measure 5 seconds with 2 hertz sampling frequency, then you get 10 measurements in theory, yeah, that get averaged and then give you the measurement. This value gives you the number of valid single measurements within that averaging time. So perhaps there's a lot of noise on the ground. Perhaps you have very turbulent water and not all radar signals are reflected back to the radar. So perhaps out of those 10 samples that are taken, only 2 are valid. And in that case, it's the question if you want to trust that data. Perhaps something is wrong with the measurement. There's a new turbulence because of a new rock or a tree. And so you should go out and figure out if something's wrong there or something has changed there. A new quality indicator for the level measurement is the indication if you have a strong or weak radar signal. And you will get a value between 0 or 3, and that indicates you, how good the radar signal is that is reflected from the water surface. Our tests show that usually you have a strong radar signal. If you have a standard measurement site, you get a strong radar signal back. No radar signal is really just if you point at the sky to nowhere, then you get no radar signal. If you have a weak or medium radar signal, something is wrong with your measurement site. Perhaps there are leaves or trees or grass in the measurement path, so you should check that. And then if you want to dive deeper into the data, then you can also determine this or look at the signal amplitude. So that's just how the device status looks like. You can also find that information in the manual. So depending on what status message you get a number along with your measurement. For example, 16 means that the radar sensor is not pointing downwards. It's pretty much the same as you know from the PLS 500. Then you have a quality indicator, as I already talked about. 0 means no radar signal, 3 strong radar signal, 1 and 2 means something's wrong there. Okay, let's talk about internal statistics and calculations. And as I said, again and again, it's very, very similar to the PLS 500. So if you are already familiar with the PLS 500 and the data processing that it enables, you will find that the RLS 500 operates very, very similar. As said already, the RLS 500 samples the water surface with the radar beam at least twice per second. And one single sample takes approximately 100 milliseconds. And then the sensor calculates an arithmetic mean value from several samples over the adjustable averaging period. So the factory setting for the averaging time can be set between 1 and 60 seconds. The factory setting is 3 seconds. So one advice here, the factory setting for the existing RLS was 20 seconds. Now the factory setting is 3 seconds. Of course, the data does not look that smooth with a 3 seconds averaging compared to a 20 seconds averaging. Customers in beta test kind of complained, at least they noted, that the data was not as smooth, it was more noisy. So if that is the case, if you want to have a more flat time series, then increase the averaging time. So if you increase the averaging time to, for example, 20 seconds as you had it with the existing RLS, then also the data will be more smooth. Yeah, and over this averaging time, you will in addition get statistical values. So you get the mean, of course, the average value, but also min, max values, a medium value, and very important, the standard deviation. And in addition, you can get the last instantaneous value. As I said, the RLS 500 can calculate and output discharge using rating tables. So the input the user needs to add the rating table to the sensor, of course, or using the ISO exponential formula. And all that data gets then provided via SDI12. So here is just a screenshot of how that will look like. So you can issue the M1, and the M3 command to get all the values that I was talking about. To make it easier for you, I really recommend using the USB SDI12 adapter for configuring the RLS 500 or any other odd SDI12 sensor. With the PLS 500 2 years ago, we also improved this adapter, and now it also is able to power the sensor via USB, so you can directly power the sensor via this device and then configure the sensor. So no external power required. Really highly recommended. It's a really cool tool, and it offers you a graphical user interface to change the SDI12 settings. There are 3 operating modes available with the RLS 500. First of all, that's the standard mode for a SDI12 sensor. It's a single measurement mode, and the sensor in that case is by default in sleep mode and performs 1 measurement after a SDI12 request. So that's very good for power saving applications, and that mode is available with SDI12 and RS485 in parallel. So if a measurement has been triggered, and for example, in that case, the sample rate is set to 2 Hertz, the averaging period is set to 5 seconds, then the RLS 500 takes 10 samples and provides after 5 seconds the average value via SDI12. So, and as I said, the sampling rate and the averaging time can be changed via SDI12 commands. And what's new is the continuous measurement mode. In that mode, the sensor is at all times active and performs continuous measurements. In that mode, the response times of the SDI12 interface depends on the mode that you set. The Modbus protocol is only enabled in this mode. So if you want to use the Modbus protocol, you need to activate the continuous measurement mode. SDI12 is still available in that mode, but not in parallel at the same time. And within this continuous measurement mode, you have 2 different sub-modes. One is the interval mode and one is the sliding mode. So in the interval mode, it's very much like the sampling mode. You average over 5 seconds, for example, with a sampling rate of 2 Hertz. So you wait for your 10 samples, the average is output or the average is provided, and then already the next measurement starts. And again, here the averaging time and the sampling rate can be set. The floating mode then operates in a different way. So in that case, you could, for example, set that a mean value is provided every second. So you don't wait for the 5 seconds to pass. Or 3 seconds in that case. No, you can provide a mean value every second. Okay, so let's go to the more practical stuff, installation and site selection. There are several criteria for selecting a suitable mounting location, and overall, this information has not changed too much from the existing RLS or any other radar level sensor out there. So possible mounting locations are bridges and any kind of constructions directly above the water to be measured. But take care, the mounting point must be steady, so vibrations and movements of the mounting point must be avoided. And that can, for example, be mounting arms that are not very solid and are affected by wind or temperature changes. And also bridges. Be careful with bridges. They can be affected by movements of several centimeters because of load changes. So if you have bridges that are regularly crossed by big trucks or trains, they will have high vibrations. And of course, in that case, also the sensor is vibrating, and that will affect the measurement. Countermeasures to that are choose the installation close to a bridge pier. So there the vibrations are smaller, or take bridges like pedestrian bridges that are not that much affected by vibrations. And if you have small vibrations, take longer averaging intervals. Then the area within the sensor beam must be completely free of obstruction. So that is the sensor beam, and of course that footprint and the diameter of the sensor beam increases with the distance to water. So here's a table representing that. At 1 meter measuring distance to water, you only have a 14 centimeter diameter. At 30 meters, you already have 4 meter and 20 centimeters diameter. And that needs to be completely free of obstruction. So if you are close to a wall or a bridge pier, it may not touch the diameter. So you need to move away with the radar from that obstruction. And in addition, also avoid turbulent areas here, avoid areas where foam is created, avoid search areas where obstructions or bridge piers cause changes in the water level. That's true for all radar measurements. The measurement results are invalid if there is ice or snow cover on the water surface. Also take care that in the measurement diameter or the footprint also needs to work in low or high flow conditions. So in low flow conditions, often you have rocks submerging to the surface. So that's not good. You cannot have rocks in here. And also in flood events, it should still work. Please avoid large metal surfaces near to the sensor beam. Sometimes that can cause reflections and distort the measurement. But overall, due to the smaller measurement diameter that we now have with the RLS 500, you can also use it in wells as long as they are large enough. So rule of thumb is that the diameter of the well should be 2 times the diameter of the measurement footprint in the respective depth to water. So overall, with the RLS 500, You gain more flexibility with installation because you do not have a blanking distance here, and you have a smaller measurement footprint due to the smaller beam angle. So how to mount the RLS 500? There are two options for mounting it. One is with the housing bracket that you see here. You can either mount it vertically or horizontally to any kind of wall or whatever you have. In addition, the swivel mount or wall bracket can be ordered as accessory. That is a difference to the existing RLS. In the existing RLS, that wall bracket was always in scope of delivery. Now the wall bracket is an accessory. So the RLS 500 just comes with the housing bracket. Important to know, the wall bracket design has not changed. So you can also reuse old wall brackets that you might have. If you, for example, replace a sensor at the measurement site, you can keep the wall bracket and just use then the new RLS 500. It will fit in there. Yeah, so this wall mounted allows you the alignment of the sensor in 2 axes. The housing bracket only allows you the alignment in 1 axis. Maintenance, yeah, not much to say about maintenance. The RLS 500 is almost maintenance free. There is no setting or calibration work necessary. There's nothing that needs to be replaced. There's just a little bit, like with any high precision instrument, that you should do. Check the RLS 500 for dirt. And in that case, carefully clean the sensor lens. And important to know that only this white bubble here, this is the sensor lens. This is used for measuring. Everything around it does not affect the measurement. That's not the measurement, the radar lens. So only this white bubble is used for measurement. Also, we've heard concerns that in the gap between the housing and the sensor inside, wasps also could nest. So we will address that by closing that gap with an inlet that also can be retrofitted. Yeah, and so again, for maintenance, also check the alignment of the sensor if necessary. Perhaps it got hit by a tree, and so you need to realign it to the water surface. So overall, dirt, spider webs that are not on the radar lens do not affect the measurement. Accessories. As I said, the USB SDI12 adapter that is available already. Perhaps some of you already own such a adapter. Highly recommended. And then, of course, the cables. As I said, the RLS 500 can already be ordered along with the right cable, but the cables can also be ordered as accessories. And you see here, it comes with a cable socket, and you just do a plug connection there, so you can plug the cable in and then screw it on, so to tighten it and it doesn't get loose. The color assignment of the wires is the same that you know from the PLS 500, so no change to the PLS 500 there. The cable is available in different lengths, so from 5 to 50 meters, or even 100 meters, I think. Additional accessories. I will jump over that. One thing, if you want to extend the cable, that's also possible. You can just use a terminal box, any kind of terminal box. We have this one here and even more terminal boxes to extend the cable. Perhaps there's a cable already there, or you want to connect several sensors. So then you can, of course, use a terminal box. Yeah, as I said, there's the wall bracket as installation accessories, bridge mounting unit, and then also a pole mounting unit to use, to install different kinds of sensors to poles, either vertically or horizontally. Also, there is an accessory to combine the SVR 100 with the RLS 500. It's the same that you know from the existing RLS. So you have a combined velocity and level measurement with that device. Yes, some additional information for you to help you when you are out with customers to convince them on the RLS 500. Yeah, the benefits of the RLS 500 are definitely that it has a reliable and robust design. You can be sure that if you have it installed, there won't be any product failure, and you will get informed if something's wrong out there. So you have trust in the data for confident decision making. And it's also there to optimize resources, as most of the factors that influence the sensor can be determined remotely. So as I said, the design is hydrology tailored. It is by hydrologists for hydrologists. And with that, it offers you the highest reliability and also the highest flexibility with different mounting options, the small and rugged design, it has no blanking distance, and the narrow beam angle for a small measurement footprint. It is really easy to maintain, and it is really easy to order. And the odd hydromet service is there to support you. Some things about compliance. I know we have an international team here, of course, and so that's an important point. You know, everything that has high frequency radiation is difficult to certify in certain countries, and it needs additional certification in most of the regions of the world. That said, we currently have country compliance for Europe with CE, for USA with FCC, for Canada with IC. The certification for South Korea, Brazil, Colombia is currently pending. I think for Chile it's also pending currently. And if you are interested in introducing the RLS 500 to other countries, we have created an add country process. So please contact either me or the odd manager that is odd sales manager that's responsible for your region, and we will get that add country process started for your region. The RLS 500 is not compliant in India and China. So in those countries, the technology is not compliant. So some things need to be considered when ordering the RLS 500. Let's start with that. First of all, you need to decide on the default RS485 protocol. So that can be changed later, but yeah, when you receive the RLS from the factory, the RS485 protocol can be either set to SDA12 or Modbus. You can also select the default units, so either metric or imperial. That also can be changed later. What's new is that you can order that you should select the right cable length. So as I said, it can also be replaced later. It's field replaceable, but when ordering the RLS 500, it always comes with a cable. And what's also new, it can be ordered with or without mounting bracket. It's absolutely not recommended to order it without a mounting bracket. If you need a spare sensor or you have a tender where mounting accessories need to be separate, that is possible now, but it is not recommended. So in the end, you can just use it with our mounting bracket. So if you order the sensor without, you need to order it as spare part or accessory. If you then receive the RLS 500, you will get, of course, the sensor, the housing bracket. As I said, highly recommended. Don't order without. Then you will get the cable that's also in the box. One thing that's wrong here, you don't get the manual anymore. You will get an information sheet with a QR code and a link where you can find the RLS 500 manual, and you will get a factory acceptance test. Important, the wrench is not included anymore. The RLS, the old RLS came with a wrench that is not included in the delivery anymore. Yeah, that's it for this presentation. Thank you very much for your attention. If you have questions, type them in the chat or let me know, and I try to answer them as good as possible. If you have questions later on, also you can use either this chat or you can send me an email at hannes.tietz@otthydromet.com.
Thank you.
You're welcome.
Thank you.
Thank you.
Thank you very much.
Yeah, you're welcome.
Thank you, Hannes.
Also, the presentation on Friday will have the same content, so no need if you were fine today, so you don't need to get to that presentation.
Thank you.
If there are questions on Friday, then I will also share them with this group.
Okay, thank you.
So if there are no questions, I will close that meeting. Again, thank you very much, and yeah, have a great day. And let me know if you have any feedback, comments, questions. I'm also always very open on that to learn